Hello and welcome to this video. In this video, I'm going to review the solubility chart, which is the chart that we use in chemistry for determining whether or not an ionic compound, again, the solubility chart is only for ionic compounds, whether or not that ionic compound is soluble or insoluble in water. Now, why is this important? When we're writing reactions, we have to determine whether or not our compound is solid or aqueous. In Chem 20, you learn how to write dissociation equations, and that differs whether it's solid or aqueous. Okay, so here is a quick review on how to do that. Now, whenever you're using your solubility chart, there's always two ions making up your compound. Think of the name. In this compound, I have magnesium ions and I have nitrate ions. This compound is called magnesium nitrate. Okay. So when I'm looking at figuring out the solubility of this compound, I'm going to look in the header for one of the ions in my compound. Usually the negative ion. We call the negative ion the anion. Nitrate is right here. Okay, so now I'm going to look if in the bottom row there is the compound magnesium nitrate. If it was down there, it would only be slightly soluble or insoluble, and we would say that it's solid. If it's not in that list, then it's up here. So it says here that most everything, or everything else, other than the list of those compounds down there, are very soluble or aqueous. Okay, so with nitrate, magnesium nitrate is not a list of compounds that is solid, so it fits into what most everything else or everything else does, which is aqueous. So we say that that compound is aqueous. Okay, calcium carbonate. So this compound is made of calcium ions and carbonate ions. So the carbonate ion is right here. Now most ions are going to be solid, insoluble with carbonate, okay, unless it's a group 1 ion or the ammonium ion. Group 1 ions are the first column of your periodic table: potassium, lithium, sodium, hydrogen. Okay, all of those ions that are in group 1 on your periodic table, they are the ions and ammonium that would be aqueous with carbonate. Everything else, including calcium, which is not a group 1 ion, is solid. So that compound is solid. Okay? So you're again basically reading the chart where you're looking at, does it fit in the top or bottom row, and if it doesn't, it's in the other row. Okay? If it's in the bottom row, it's solid. If it's in the middle row, it's aqueous. So let's try another one. Barium sulfate. I have a compound made of barium ions and sulfate ions. So my sulfate is right there. Here's a list of ions that are solid because it's in the bottom row with sulfate, and barium is right there. So that is insoluble, okay, or solid. Next we have potassium hydroxide. Hydroxide is right here, and it will be soluble with a group 1 ion or ammonia. So you have to check, is potassium a group 1 ion? It is. It's in the first column of your periodic table. So that will be soluble. Now the last one is a little tricky. Okay? The last one is lead, which is a multivalent metal bonded with sulfate. Okay? Now, when you have a multivalent metal, multivalent means it has more than one charge. You have to figure out what charge it has in this compound. Because it's balancing with 2 sulfates and each sulfate is 2 negative, that means the lead must have a 4+ charge. So when I'm looking at sulfates, again, this was my sulfate. Lead with a 2+ charge is listed down here as being solid, but I don't have lead with a 2+. I have lead with a 4+. So that means it fits up here instead and is aqueous. So be careful of multivalent metals like lead 2+, mercury, iron, all of those multivalent metals. You have to check what charge they have specifically in that compound to see if they actually fit in that row or the other row. I hope that was helpful.